So we said the network layer is responsible for delivery of individual packets from the source host to the destination host. Okay, keep this in mind: host to host. Okay, source host to destination host. But in each of these hosts, the source and the destination, there may be different applications running. So how you deliver the data from the correct from the source application to the correct destination application. The network delivery is responsible for host to host. So you'll deliver the data to the correct host, but still you have to deliver it to the correct destination. That when the transport layer comes into function. So here is a source to destination delivery, which is the responsibility of the network layer. Okay, so there is some application sending data to this destination. For example, it will go through this path, for example, from source, and it will go all from application to physical. Then if you have a router, for example, to network layer, then again to down to physical, and so on. So the data will be encapsulated, decapsulated until it's arrived at the destination. But now at the destination, there are many applications running on this computer. So which application will receive the data? That's the functionality of the transport layer. So the transport layer is responsible for delivery of a message from process to process. Okay, here we have host to host. Host is this one, but on this host there are many processes running. Okay, so from this process to this process is the functionality of the transport layer. So the transport layer is responsible for delivery from process to process. Okay, so you have data, actually we say here from application layer, because we are talking about, I'll correct these are mistakes in the book. So we have application layer. So application layer data are encapsulated again. So the data here, this is the application layer data. You add headers. What are these headers? They are transport layer headers. So these are layer 4 headers. Okay, so this again, this will be the data for layer 2. So the layer 2 data, 3 data is this, and then you add header 3, and this whole will be data for layer 2, and then header 2, and then you deliver this to physical layer, so on. So you encapsulate application layer data into some headers. Again, what's the purpose of this header? So who can answer the question now? You should be able to answer this question now. What's the purpose of this header information? What's the purpose of this header information? Who can answer?
It shows the application that can read these data and use them.
Very good, well done. So this header will contain the information to deliver this data from the source application or process to the destination process. So process to this is the purpose of this header, to deliver the data to the correct destination process. And again, this may contain also information regarding error detection and correction and some other information, and we'll study that in detail when we study the transport layer. There are many services offered by the transport layer. Okay, so transport layer is the fourth layer of the TCP/IP protocol suite. Okay, please send me your names in chat. We start from now. 2 minutes. Now it should be clear for you. This process to process message delivery. So here the source, there are different processes running. So this process, for example, is sending the message. Okay, so the network layer is responsible for delivering the message from here to here. Okay, from this host to this host. But on this host there are many processes running. So how you deliver this message to this process, this is the responsibility of the transport layer. So the transport layer will make sure once the message is arrived here, the transport layer functionality is to ensure that this message is delivered to this process, not this, not this. Okay, so this is the functionality of transport layer, and it's actually reliable. We'll understand that in more detail when we study the IP, because IP is not reliable protocol, but TCP, Transport Control Protocol, is a reliable protocol. Reliable means if there are errors or something wrong, then the process may be repeated. You resend the data, or so it's a reliable. You have to make sure the data arrived correctly. That's meaning of reliable protocol. IP is not reliable. TCP is a reliable protocol. So I'll save chat now. Finish, please. I saved the chat. Okay. Now the last layer in the TCP/IP suite, protocol suite, is the application layer. It's very convenient. The application layer is the layer that you are working on it now. So it's the closest layer to the user. The application layer is responsible for providing services to the user. So different services available for you to use, like for example FTP, like HTML protocol, like DNS, like DHCP. All these application layer protocols are layer 5 protocols. So we have different everything that runs on this layer is called application layer service. Okay, again we have okay, this should be H5. Okay, because this also there is some confusion in the book actually. Previously we used OSI reference model, which we'll talk about later. It has got 7 layers, but in the TCP IP suite we have only 5 layers. So this is H5. Okay, and then this data will add the application layer header to this data, and then we'll send it to not presentation actually to the which layer. Who can tell me? We just what's the layer below now? Transport layer. Well done. So the application layer will encapsulate the data and send it to the transport layer. Okay. So what's encapsulation? We already mentioned this. Encapsulation is the addition of layers of headers. So when you this is application. When you send it down, you add layer 4 headers. So you encapsulate it. Okay, put headers. So this when sent down, you add more headers, you encapsulate it. So when you go down, you add more headers and so on. In the receiving side, you decapsulate. Decapsulate means what? Removing headers. So this layer will just deal with this header. Once done, it will remove the header because this header is only for data link layer. Remove this header, send the data to network layer. Network layer will process this header. Once processed, it will remove the header and send the packet up to the transport layer. Transport layer will deal with this header. This header tells the transport layer this message should be delivered to which process. Okay, so once done, it will remove the header, send it to the appropriate process, and that's it. The communication is complete. So encapsulation means adding headers. Decapsulation means removing headers. Okay, so this always happens. When you send data, you encapsulate. When you receive, you decapsulate. Okay, here again encapsulation and decapsulation happens. You receive means you decapsulate, but the router only goes up to layer 3, so you will not decapsulate this because there is no transport layer here. We only have 3 layers, so you send it back, you encapsulate it and put the layer 2 header and then send it to the network. That's the meaning of encapsulation and decapsulation. Actually, we have some specific names for the data at each layer. So in application layer, we call the data or the packets messages. Okay, so the data here we call them messages. In transport layer, we call the data segment or user datagram. Both of them are used. We mostly may use user datagram. Okay, so the data here is called user datagram. On network layer, we call it a datagram, and on data link layer, we call it frames. But in physical layer, of course, we have only bits. So bits, frames, datagrams, user datagrams, and message. Okay, so the data at each layer or the packet at each layer has its own name. So here we have bits, here we have frames, here we have datagrams, here we have user datagram, here we have messages. And the addresses are actually we use different addresses. We'll study these also in more detail. So in data link layer, we'll use link layer addresses or MAC addresses. We study these in detail. In network layer, we use logical addresses or IP addresses. In transport layer, we use port numbers. So if you port numbers, they are numbers, decimal numbers. They are used for specifying which application will receive the data. And in application layer, we have names for specific application. Or we have another model, as we said, the OSI, Open System Interconnect model, which is issued or released by the International Standards Organization, or ISO, which is a multinational body dedicated to worldwide agreement on international standards. It releases standards on different, not only on network, or different things. ISO is a well-known organization. So the Open System Interconnection Model, OSI, is an ISO. So ISO released this model standard that covers all aspects of network communication. It was first introduced in 1970s, okay, and it is actually 7 layers, okay. So we have the lowest layer, the application layer 1, then data link, then network, then transport. They all seem like the TCP/IP. Now we don't have these 2 layers in TCP/IP, and then we have the application layer. So it's very easy if you want to compare it with TCP/IP. You see, application, presentation, session, they are all the application layer of the TCP/IP. Then these are the same, network same, data link same, physical same. Okay, so just presentation and session and application, they are all merged into one layer in the TCP/IP suite. We'll use this protocol suite. Before, most texts were using this standard, but nowadays most are shifting to use this model, the TCP/IP suite. And I think we are done with this lecture.